Hello and welcome to CIS 4510 IT Project Management. Although the first chapter of the book addresses software project management, in this session I will be addressing all IT project management, such as software development, mobile application development, hardware configuration, network configuration, upgrades or updates for workstations, media, classrooms, or any other IT related projects. I will be talking in general, and then we can take specific example, which is the software development, just for now as an example of an IT project. But most of the time we will be addressing all kind of IT projects and not specific IT project. So for IT project management, to manage the IT project or to manage any project, we need the planning, the scheduling, and controlling of that project to finish within time and within budget. Um, the IT project can be any type of a project that deals with the infrastructure, the information system, or computer technology, or security, or web development. It's all included within the IT different projects that can be considered as IT projects. Although in some cases or some managers consider that IT projects is different than the other projects, the manufacturing or services or other different projects, it's not. The only difference for IT projects that we are dealing with technology, and technology has short life cycle than dealing with other maybe infrastructure or other buildings, other services that we are dealing with on a daily basis. If I'm developing a software, it cannot take 6 years or 7 years just developing a software. It cannot take more than maybe 6 months, because during that, another product will be in the market competing with my product. If you look at building a bridge, some bridges or some buildings might take 6 months, might take a year, might take 2 years, 3 years. It doesn't matter, because the building at a certain point it will be done, it will be finished, and you can move in, you can lease it or sell it, it doesn't matter. While for technology, if you are looking at a technology project, you cannot keep a server for 2 years until you finish the installation for the server and the workstations. Within these 2 years, or within even 1 year or less, you will find that technology changed, and it's outdated actually. You don't have the state of the art anymore. Already they moved on with a new technology, a new product, and more capabilities. That's why you have to be careful with the IT project more than the other projects. The end of the project, we say that the project ended when you achieve the main goal of that project. In other cases, it might be eliminated for other reasons, which is maybe it's not in need anymore, and that's rarely that happens in the IT projects. It might happen in other projects where after a month of starting a project, it might be eliminated due either to budget or due to the no need or no priority for that project for now. With IT projects, almost like 90% to 95%, it has to be done or it has to be finished, because it was not initiated without a need. It's very important to do that IT project. The IT project is a temporary with a definite beginning and an ending date. and the IT project can involve a single organizational unit or multiple organizational units. I can do an update for one unit of the organization. I can change their machines. I can install maybe a new operating system for them. I can add more RAM to their machines, new screens, all that for one unit. Or I can do it for the whole company if I can. So it depends on the size of the company. It depends on the capabilities, the money that I have, how much budget do I have to change or do that change. Based on that, we can involve either a single unit or multiple units. As an example of IT projects, as I said before, it might include, but it's not limited to what I'm saying here. It can be more, but I'm just giving you an example, which is software development, such as programming a simple mobile app or programming a large-scale software systems or a system. Also, web development can be considered a project. Designing an organization's IT infrastructure, deploying systems and software, and employing IT or implementing IT security measures. All that can be considered as IT projects. In any IT project, we have certain activities that need to be done to achieve the main goal of the IT project. The efforts or the activities involve assessing, prioritizing, and planning potential IT projects. It will include determining the scope of the work and available resources. I need to know what is the main goal of the project, and then what kind of resources do I need to achieve that goal, and then we assign the resources to the certain activities. Then we set expectation for the project milestones. Once I have that, then I will start coordinating the project workload, managing the actual activities or the actual work. I will as a project manager facilitate the communication and collaboration between team members, produce project deliverables. I will know exactly what need to be delivered at the end for the customer, and at the end it's good to measure the project results, so you will learn, or we will learn from our experience managing these projects. This is part of the learning process that we do to always improve our managing skills and do better for our clients. The managing process, like we said, we need to identify the scope of the project. We need to define the boundaries of the project, what will be done in the project and what will not be done, and that's what's called the scope, also known as functional specifications or statement of work. So we need to provide to our clients that this is what need to be done, or this is what will be delivered at the end of the project. We cannot overpromise, we cannot underpromise, and we cannot do something that was not stated in the scope. If you have certain functionalities that's been stated in the scope, it has to be delivered as promised. Like I said, you cannot add more, you cannot do less. If you add more, then people will start expecting you always to add and do things for free. You don't want to do that. Always you do what you promised within the scope. For the quality, you need to know how well the project management processes worked. And again, you can do that by looking at the results of the project at the end, or you can do buffers within the project management process during the process execution. or the project execution. You do that to make sure that everything is being done based on certain standards or certain quality management rules. For the schedule, it represents project duration and timeline, and you need to always make sure that activities being done within that time. Some activities will be critical and might push it will push your time or the project ending date to forward more or to additional time that will cost you money, cost the client money, and that will not be good for a reputation for a project manager or for the organization. So always you need to commit yourself to finish within time. The budget is the estimated initial of the project cost, which might change over time, and time and cost has an inverse relationship. As when you go deeper in the project, the cost will be more expensive to do any changes for that project, because already you did lots of execution. So you need to know that time is very important, budget is very important, and you need to finish within time and within budget. Also, to finish the job needed, you need resources, and resources can be people, equipment, physical facilities, or supplies. Resources could be fixed or variable, and of course resources has the most impact on the schedule. You could have only one person doing the job and they might take 3 weeks, and you could have two people and it might take 2 weeks, but adding another person might affect the cost. So you need, as a project manager, to look at all factors, how do they interact with each other, and make your own judgment based on that. In addition, project managers should look at the constraints, which are the factors that will affect the project, and those factors are correlated. They are linked to each other. So any change in one factor will affect the other factors. For example, if we want to shorten the schedule, that means we need to add more resources, and adding more resources mean adding more money. So shortening the schedule will increase the budget. The stakeholders may have different ideas as to which factors are the most important, and at that point, when stakeholders starting to get involved and push towards finishing in time and finishing before time or faster, but without adding any more money to the budget, then that's a problem, and that will be a challenge. At that point, the project manager either have to explain for the stakeholders the hardship that they will face if they do that, or he might push his team to finish the project, although it's not a good idea to do that. Changing any requirements, especially when the project is almost towards the end of it, or after 50%, if you change anything in the requirements, that will create additional risk for the project and for the team. And at that point, project team must assess the situation, look at the risk that will be related, look at the alternative of solutions, and look at the impact of that risk on the project, the overall project outcome. If the risk was way more than the main goal of finishing the project, or it will affect, or it will cost a lot of money, then it has to be explained for the stakeholders and the upper management that it cannot be done because we are risking more than we can deliver. So that should be addressed at that point, and there should be a balance between the associated risk and the main goal of finishing the project. To manage IT project, we need some kind of methodology. We need tools, techniques to do that, and with all these methodologies, the most important thing is to specify the best way to initiate, plan, and execute the IT project. Use the techniques and tools to monitor and control the execution process to make sure that everything being done within time and within budget, and then to monitor project time and the schedule to make sure that we are not running behind, and look at the quality of the product or the finishing or the finished work. So how do we know which system to use to manage a project, which software package, which tools or techniques? We look at the tools or techniques or methodologies or a system that will facilitate all aspects of IT project management. This system should support multiple IT project management methodologies, whether we are using maybe WATERFALL to manage a project, or I'm using AGILE, or I'm using Spiral, or any kind of methodology for maybe hardware or software, or any other project development or execution. The system that I'm using should support these methodologies. The software or the technique or tool should be easy to use. So if I'm using Microsoft Project Management, it's an easy tool to use. It can manage the project, it can control and monitor. It will show you exactly what kind of activities did you accomplish, what other activities are still to go, the milestones, and many other things, and that's within Microsoft Project. Another software or system that can be used is Primavera, which is a software exactly the same as Microsoft Project and has their own tools. So those two tools can be used as systems to manage project management or to manage IT projects, and those will be easy to use. The other thing that we look at is the cost of using that system or that software. It should be relatively inexpensive to use because it's more of management software than the software itself or the source itself that we are using to execute the project. It should be centralized to assist in the collaboration and the real-time accessibility for all stakeholders, for all people involved in the project. So it should have the ability to share the information with other people within the project or during the execution of the project. As an example of an IT project, we will look at software development, and the software development is a project that might be late, might be over budget, might be unpredictable. Sometimes the entire project fails before even delivering the application, and the reason for that we have lots of uncertainty and risk associated with software development. When we are developing the software, we don't know in which direction we're going, and we are trying to capture the customer needs in a certain way, the different functionalities that's required within the software. And as you go, you will find more and more requirements, and people are remembering that they need this functionality or that functionality to be included within the software. Those things might push the software development or the project to be late, to be over budget, because they did not expect adding all these functionalities, or maybe spending time on the testing process more than expected, and so on. So all these actually might affect the software project deliverables. The software project can often go out of control and become a runaway system. The best thing to do is to actually use effective project management that can keep software development under control. At that point, software development can be executed properly and according to customer requirements, and to the developer design within specifications and within certain limits. Any other changes should be appended, or should be added with a certain budget or a different budget. If you do that, then you will control the time, because you don't have to reflect the changes that's been made by the stakeholders on the main effort that's been done to finish the developing of the software. Software is designed and developed to ensure that it should be maintainable and extensible. In case of if I need any help or any maintenance, it should be easy to do that. So you'll have either documentation that will be given to the client, or you will have a support team stand by to answer the questions needed to execute or to use or utilize that software. In addition, in the future, if you need to add additional functionalities, then you will be able to do that. Designers should make sure that it's easy to install and easy to use, and that can be done through surveys and through consulting with customers and stakeholders. The different methodologies that's been used in software development, there are certain methodologies that can be used, such as waterfall. I will talk about that in a minute. The agile, the spiral, and prototyping, and those are some methodologies used in software development from many different methodologies, and maybe those are the common ones, and sometimes there are others that can be used. For the waterfall methodology, it employs a sequential top-down approach to the IT project, where we look at the current situation, we analyze it, and then we design the software to address the needs with the current situation, and then we implement the software, start testing that software, and after the testing and evaluation, we are sure that the software will do the main functionalities requested by the customer. We deploy that. After that, you might have some iteration between the first released software package and the last one, but even with that, you should have a maintenance plan after that to make sure that you are updating the software and you are making sure that the software doesn't have any glitches during customer use. Project managers in waterfall methodology strive to eliminate risk and uncertainties by outlining all the steps in a project and defining its scope, budget, and schedule upfront. So they know what they are facing and they know how to solve the problems if needed. Most of the time it's covered. They know everything, they know what's been done, and there is a slight percentage of an error that might happen, and at that point again it will be expected. And if it's expected, if that happens, then the mitigation of the problem is available and can be treated immediately, so they don't have to worry about that. But usually in waterfall, because it's sequential, they know exactly what will be coming up and how to deal with it. The other one is the agile methodology, and the agile is a change driven approach that gives IT project teams the dynamic ability to quickly adapt to needed changes or course corrections. And again, you do the same. You analyze the situation, you start the design and development, you test and evaluate, you release it to the client. Once it's been deployed, then you have to maintain. It might have a certain iteration before it's been released to the customer, but it will all follow the same procedure, which is the analysis and testing procedure or main processes. The agile versus the traditional fall, you can see in this table, it talks about the different or the differences between the agile and traditional waterfall. And you can see that with the agile, it's closer to customer. You can capture their needs, you can actually get their feedback and adjust more frequent and better than the traditional waterfall. By doing that, you will have a product that is more closer to specifications than the waterfall. And again, always the specification will change during the execution of the project, especially with software development, with the discovery of certain cans and certain can'ts, and you will know that this can be done and this will not be able to be done, and based on that you do the proper changes. Since each software development methodology has its advantages and disadvantages, of course, some software project teams take more of a hybrid approach, and they can mix two methodologies or three methodologies together based on their needs. But that's not something far from doing. It's easy to be done, and lots of project managers does that to make sure that their project is being done properly or is being executed properly. The software, when we say software artifacts, actually we are talking about the items that's needed or that's been done within software development process, such as writing the code, and the code will be based on requirement specifications, and there will be a design document, there will be user help text, and there will be test cases to make sure that we are covering all scenarios that might face the user, and then we will have a reference manual and other materials created to support the code. Now, some artifacts can be considered as project deliverables because it will be given to the customer at the end of the project, and others can be just internal, for internal use only. It's used for internal training for the employees and for the project managers for future projects, or as a reference for future projects to know what's been done in a certain situation. The core activities of software development is the requirement analysis, the functional specification. So you first you can ask the customers or the stakeholders. You collect and document through interviews and surveys the requirements of the project, and once you have that, then you translate those requirements into functional specifications for the software that describes the requested behavior of the software, and that will be considered as the technical mapping of requirement document to the functional specifications. The architecture is the high-level structure of the software, which facilitates communications between stakeholders, and it captures early software designs decisions and allow reuse of design components between projects. Of course, after that we begin with the constructions, and the construction includes the build-up or the coding for the software package, and then the different designs that we can use. After that, we start testing the software to make sure that it's working up to specifications. If we have any problems or any errors, then we start debugging the software to make sure that those errors being addressed and an update being done to the software. And then after everything being treated well and being addressed and discussed, it will be deployed with maintenance plan included to make sure that it will be maintained over the years of use. The most people involved in that is called software engineering, and those are engineers with the ability to deal with software development. And software engineering is the art and science of developing and applying a body of knowledge and methods to the certain or to the creation and support of software specifications and functional requirements. We are just applying that knowledge that we got into the creation of the software and supporting that software after it's been released. This figure shows the software product life cycle, where it starts from user needs, capturing the requirements and gathering the specifications or translating the requirements into product specifications, then designing that software, writing the code, testing and integrating that software. Then we do the first release. With the first release, we start capturing user feedback, and from user feedback it can be updated or changed with multiple iteration until we get to release N, or the final release. And again, when we say final release, that doesn't mean that there are no updates coming after that. Actually, there should be a maintenance plan and update plan that will be released with the product, where it will be updated either on a yearly basis or maybe less than that, just to make sure that it captures all or addresses all the problems or debug all the problems within the software. If we go back now to the management aspect of it, once we have a software project, then we need to manage it, and to manage that we need to go through the phases of IT project management, which is the initiation of the project. We start with sitting with a customer, capturing the needs, know exactly what they need, and then we develop a scope for that project, and with the scope we specify the uncertainties, the risk, the budget, the cost, the initial cost. All that will be estimated, and it will be signed from both parties to make sure that this is what we agreed on, this is what will be done within the project. And this is called the initiation. Now, once you get the project and you are assigned to do it, you will start planning on how it's been done. Already you know the different activities needed, or how to do or to execute the project. So you start the planning on who will be doing that job, and how long would it take, and how much money do we need. And once you have the planning, you start the execution, and with the execution you need to monitor and control, making sure that everything being done within time and within budget. If there are any changes, then you need to adjust as needed, and after that you deliver all the products or the promised specifications to the customer, and you close the project with the agreement to maintain or update as needed. And we'll talk about the project management aspect of it later on in different chapters. That will be all for this session. If you have any questions, please email it to me, or you can Skype with me if you like, and I will be more than glad to address all your concerns. Thank you and have a great day.